So welcome everyone. My name is Paul Dodd. I'm the Associate Vice Chancellor for Research at UC Davis. I'm delighted that we have the opportunity to welcome colleagues from a number of universities here today for this discussion around the HIBAR approach to research, which is highly integrated, basic and responsive approaches. So we have colleagues from the University of Idaho, from the University of South Florida, and the University of British Columbia joining us today for this session. So we started an online program a few months back at UC Davis called Research Pathways to Impact, and we've had a number of sessions where we've looked at different topics such as engaging with policymakers, the future of international research collaborations, and some other broad topics. So today we're going to focus on approaches to team science and team research, where particularly there has been a profound impact from what may start off as relatively fundamental or basic research, but be rapidly translated. So we have a couple of great keynote speakers in Professor Richard Mitchell-Moore from UC Davis and Professor Sylvia Wilson-Thomas from University of South Florida. So with that, I'm going to hand over to my colleague Scott Slovich from University of Idaho. Scott is Associate Director of the HIBAR Research Alliance. He's also a University Distinguished Professor of Environmental Humanities and a Faculty Fellow in the Office of Research and Economic Development at the University of Idaho. Over to you, Scott.
Thanks very much, Paul. And thanks to all of you for joining us for today's webinar. As Paul said, today's session is serving multiple purposes. Not only is it part of the UC Davis Research Pathways to Impact series, but this is the 8th event in the webinar series sponsored by the HIBAR Research Alliance, otherwise known as the HRA. The HRA is delighted to team up with two of our member institutions, UC Davis and the University of South Florida, for today's meeting. Future events in the HRA series will be advertised on the organization's website. So at this time, I would like to introduce Dr. Lauren Whitehead, the director of the HIBAR Research Alliance and a special advisor on entrepreneurship, innovation, and research, and professor of physics at the University of British Columbia. Normally, when we do these webinars on the concept of HIBAR research, we begin with a brief presentation by Lauren Whitehead, offering an overview of the concept of HIBAR research. Lauren, I think you should be able to share your screen and talk to us a little bit about HIBAR research. Just in time.
So hello, everyone. I will just try to do the screen share thing. So first of all, Scott, thanks very much for the introduction. It's really nice to be here and have a chance just to introduce our very interesting discussions today that are focusing on work that combines excellence in research and also public benefits. And I've been asked, as Scott said, just to briefly talk about the idea of HIBAR research and the HIBAR Research Alliance. So this term HIBAR research is just a way of describing really some time-honored forms of research that have a combination of principles that are really very helpful. So I'm going to mention those principles, also summarize what the HIBAR Research Alliance is attempting to do, and then we'll get underway. So first of all, it's normal in research discussions to try to categorize research in various ways. And I think many of you are familiar with this term use-inspired basic research, which describes projects that have public impact and also are discovery oriented. So this is a very common term nowadays within the NSF, for example. There's another way that's also important for classifying research, and that is to think of it in terms of work that has societal co-leadership, partnerships with people, leaders in the real world, and work that matters, work that has sustained urgency on worthwhile projects. This is just a different lens. And the exciting thing is the notion that it's possible to have all of these good things at the same time. So the thing I just mentioned, we can call highly integrative for that connection with society. And the use-inspired basic research, we sometimes call basic and responsive work. And the exciting idea is that it's possible to do all of those things at the same time. It's possible to have research that has all those characteristics. And we've labeled that HIBAR research. It's not a new idea. It's been around for a very long time. But it's not the most common form of research, understandably. There are 4 kinds of excellence that are combined. So that's what I'd like to talk about a little bit, and to talk a little bit about the significance of particularly one of those four things today. And that is this idea of projects that have co-leadership with folks in society. So to describe that or to think about that, it's very common to talk about this continuum I portrayed at the bottom of the chart here, going from university, purely academic university work, to kind of the opposite extreme. We're all familiar with that idea. But it's helpful to be a bit more thoughtful about it and to consider that actually, if you look at individual research projects, you'll often find them located at specific points on that continuum. There's no need to be too well defined about it. But the key characteristic is that all of these are wonderful, of course, they're all great research. And if you're at a particular point in that continuum, there's a kind of a look and feel, depending on the field that you're in, for what the work is like, culture and atmosphere. And very often, most of the people involved are kind of localized in that position, in that continuum, which is just fine. But it's not the whole picture. The other form of research, which we're calling HIBAR research, has this characteristic that it has leadership that spans this entire range, so spanning research. And the key idea there is that research of that type is more complicated, and so it really requires excellence in leadership. So that's a key point. But in addition, those leaders collectively bring excellence from all portions of this continuum. So that's kind of the idea about the leadership frame. And now I'd like to talk just a little bit about that leadership frame. And this is the part I'm not sure it'll work, but I wanted to show you an example. You know, when we think of human leadership and interaction, we often turn to examples. The example I'm hoping to turn to is the television series Star Trek. So, and of course, I'm going to be a bit joking here, certainly not reflecting on any of the people that are here with us today. But if you think of Star Trek, or for those that may not be familiar with it, the key notion there was collaborative leadership among people that had slightly different perspectives on things. So Spock, highly theoretically oriented individual, not very emotional, but he certainly played a key role. And Scotty, on the other hand, highly practical engineer, also a very bright person. They were very different, but they had to work together for the ship, the Enterprise, to survive. So I'm going to play you a little clip, and I'll also show you the words associated with this very short, 13-second, I think, clip, showing an example interaction when there was a real problem.
It is useless, and there's no question it's deliberate. Sabotage. Aye, and a thorough job. That's what worries me. Worries me, sir? It's fused all right, but it would take all the power of our main phaser max to do it. I find nothing interesting in the fact that we're about to blow up. But the method is fascinating.
I don't know how many of you heard the final words there, but the method is fascinating. But I love this as an example of human interaction, kind of at its worst and also at its best. But human interaction is at the core of leadership of HIBAR research. And I think we'll see examples in the discussion today that will help us to reflect on that. Now, the HIBAR Research Alliance itself is democratically organized by a group of universities and other organizations. But its purpose really is to help a network, much larger network of individual volunteers from universities and from companies and from research organizations outside the university system, who are, thanks to the efforts of the HRA, well organized and united in their support of HIBAR research. So the goal of those folks in the HRA, and by the way, more are welcome. We'd love to hear from you if you'd like to become involved. Yeah, the goal is to increase the prevalence of university HIBAR research from about 1 project in 20 today to about 1 in 5 by 2030, while improving all types of research. We believe that that's possible, and it will, of course, be valuable to have more research with these characteristics, but it will also help universities to respond more effectively to societal needs, while also increasing the excellence of their fundamental research. So as near as we can tell, there are only winners if we can find better ways of doing more HIBAR research. So just to wrap up and to transition to the rest of our discussions today, I'll just mention that the discussions the projects you'll be hearing about reflect those 4 key characteristics I mentioned at the start of this short slideshow. The work is discovery oriented. The research seeks new knowledge about COVID and its treatment and prevention. There's public impact. The research is solution oriented with a goal of lasting improvements for human health. There's societal co-leadership. That means the work emphasizes trusted, equitable collaboration with non-university partners, including healthcare practitioners and patients. And then there's also sustained urgency, by which we mean there's an aim to achieve enduring solutions by taking the time to build trust and shared understanding, but then to move forward with that urgency that I mentioned. So all of those characteristics are here today. Let's look out for them as we move on and hear from our guests. And I'd just like to wrap up, Paul, by handing over to you and saying thank you for the opportunity to share this.
Great, thank you, Lauren, for that quick run through of what the HIBAR research concept entails. And I think many of us can probably recognize or acknowledge that type of research you described, but may not have heard of the phrase HIBAR before. And I think actually our next speaker is probably a great example of that. So our keynote speaker, from my perspective, at least from UC Davis today, I'm delighted to introduce my colleague, Professor Richard Mitchell-Moore. So Richard is the founding director of the UC Davis Genome Center and a distinguished professor in no fewer than 3 different departments from what I can see: plant science, molecular and cellular biology, and medical microbiology and immunology. So Richard is going to give us about a 12-minute talk, sorry it's so tight, Richard, on the deployment of a rapid saliva-based testing program for SARS-CoV-2. Over to you, Richard.
Great. Let me just get this right. Okay, so right. I was charged with a very broad remit to try and get basically an hour's talk into 12 minutes. So let's see how we go. So what Paul asked me to do is to describe the rapid deployment of our saliva-based testing program for SARS-CoV-2. The goal of this is to provide a rapid, inexpensive, high-throughput testing for COVID, and also more latterly to monitor for variants of concern. I come from an ag biotech background. I was very familiar with the technological capacity in the ag biotech sector for doing literally millions, generating millions of data points a day. And I grew somewhat frustrated with the lack of testing and the mentality within the medical community who thought 1,000 tests a day was high throughput. So I reached out to people that I knew in the ag biotech sector. The middle machine there is capable of doing 150,000 data points a day, but its endpoint, the one on the left, the IntelliCube, is capable of doing 12,000 data points a day and is qPCR, so that's what we went with. And the reason you can do this is you have basically arrays of essentially microtiter plates, 768 wells on this tape, and you set up the reactions and you run it through these machines. I did consult with the ag biotech sector, and some of the lessons from that is you need fast, actionable data in real time. Don't sample more than you need. The workflow's got to be robust and tolerant to sample heterogeneity. Minimize the number of samples. Keep the workflow simple. Get into the microplate format as soon as possible. And to minimize costs, use small reaction volumes. These were kind of the lessons that came out and are somewhat different from the way the medical community looks at the world. I campaigned for funding, and after about 6 weeks, 8 weeks, they gave me the green light on August 4th, and then told me 2 days later that they wanted to start testing in 6 weeks. We fast-tracked everything, and we were starting to run samples for QC in about 6 weeks. The regulatory environment was bouncing around as to whether we needed to be clear or not clear. Eventually, it transpired that maybe we didn't need to be clear, but we, by that time, had decided to be clear anyway, because it cut down the reporting time. We, in the Genome Center, we set this up. It's a pop-up lab. It's a CLIA certified extension of the student health high complexity lab. We initially were doing 1,000 students a week. It's 2.5 the second week, 4.5 the third week as the students were coming back to campus, a really rapid ramp up. And we subsequently expanded to all students, faculty, and staff with at least weekly testing if they're coming onto campus. And then we expanded to Healthy Davis Together, which is the whole of the city of Davis, and talking about sort of community involvement. You know, Healthy Davis Together is a collaboration between the city of Davis and the campus. Obviously, COVID doesn't recognize campus boundaries, and so we're really trying to form a sort of a testing bubble fairly loosely, and of which the testing and diagnostics and the contact tracing and that kind of thing were integrated completely. But it was part of a much bigger deployment. The way it works is you make an appointment online, you get a QR code, you show up at the kiosk, and your QR code is scanned. It's linked to a small barcoded tube. That's only a 0.9 ml tube. You're given a little bit of water, you rinse it, and you spit into the tube. If you want to know more, there's a YouTube video that people can go to see what to expect. The testing kiosk looks like this. We took over 4 basketball courts, and this was much higher throughput. And in fact, although home collection sounds good, this is much less work. You don't have to make up the kits, and you're much more in control. So we have a capacity of collecting 32,000 samples a week. It's got a big staff, half of which were actually repurposed from housing and dining. So the campus didn't have to let these people go. We continue to employ them. We get very high level of compliance, about 90% on campus. And so, you know, this was really efficient. This was the way to go. The workflow, they say saliva, the tubes get put in a 96 rack in the format right to begin with. We devitalize by heating. One of the breakthroughs, interesting thing was, one of the problems of working with saliva is, as you know, it's got high viscosity. Someone working in the Genome Center had the bright idea of using papain, otherwise known as meat tenderizer. And in fact, the major role of papain with papaya is to chew up the insect gut mucosa. And if you put it into saliva, viscosity problem gone. And very simple transfer, semi-automated into 384 well plates, put it on the machine there, you see the IntelliCube, and it sets up the reactions, runs the reactions, spits out the data into the cloud when we can then call the positives. And this has allowed us really high throughput. We've just, I think this week actually we'll hit 500,000 tests, and we report back about a third of the tests the same day. And by the end of the next day, we've got close to 92–95% of reports. Transitioning then, so we have a high throughput. There's been a lot of concern about variants. I know viral variation is inevitable. Mutations occurring all the time, but most of those mutations are inconsequential. But a few, if you put a virus under a selection pressure, it will evolve. And we've seen it evolving for increased transmissibility, as in the strains there. As you roll out vaccines, that's going to be a very steep selection pressure to render the vaccines less effective. I think it's a question of when, not if, we have vaccine breakthroughs that are going to essentially negate the effectiveness of vaccines. Some people predict that'll happen in less than 12 months. So it's really important that we're able to monitor for variants. We've been collaborating with the company LGC to develop SNP genotyping. The machines that I just showed you were actually designed to monitor SNPs, implant genotypes, very high throughput. So it's perfectly appropriate to roll this technology out for detecting SNPs. Now we take all our positives, we genotype them at 14 loci, and we know whether we've got a variant of concern within a few days of sample collection, way, way faster than sequencing. That is the convention of the way that people are doing monitoring at the moment. And then we report the data back to the Yolo County Health Officer. She really trusts our genotyping, and it's been a very close interaction with them as we roll out containment and response to COVID. Last slide here, really, or not almost the last slide. You know, I think there is a great opportunity for various labs, academic and otherwise, to look for variants of concern. It's very low tech. Anyone really with a conventional PCR machine and a fluorescent plate reader can roll out this technology. And we really need to do this on a global level, but also certainly we need to do it at a national level. It's complementary to sequencing for identifying. You still need to sequence. Not saying you don't need to do that, but you use that to identify consequential variants. But for monitoring, you should be doing genotyping rather than sequencing. And there's this continual development cycle as sequencing develops new variants, new SNPs of interest, diagnostic. The development cycle can be 3 to 4 weeks before deployment, which quite honestly, often right now with sequencing, it takes them 3 to 4 weeks to get the sequence back. The bigger challenge than technical is regulatory acceptance, and I'm campaigning for this. And ultimately, I think we're going to need to get FDA approval for genotyping by CLIA labs for when a patient comes in, there's a breakthrough, because they will result in different treatments. So the final point I want to make is that this was a massive effort from all across campus. There was tremendous buy-in by the administration. If you look here, there's people in purchasing, people in HR, people in health and safety, communications, and then the Genome Center, we were able to repurpose a lot of people. And then the art kiosk had, you know, a staff of 60, 2 teams that were coming in, non-overlapping. Many of them repurposed from housing and dining. We also had students working as part of their experience. And then data management, of course, is really important. And then clinical oversight. We have the MDs very closely involved to roll out this information. So in response to what Paul said about HIBAR, and he asked me to consider, why did this work? And I thought about this, and really, I think it worked because we already had a high complexity service-oriented facility in the form of the Genome Center. You know, we have cores that are providing enabling technology to the whole campus already, and particularly the DNA core could be repurposed and have experienced personnel to do this. We didn't accept the status quo or conventional wisdom. Everyone was saying at the time that swabs were, you had to do this. We consulted with other people, and saliva is obviously much easier to collect from. People don't like having something stuck up to the back of their nose, and to get a high level of compliance, it really needs to be easy collection. And so we went with saliva, and this proved to be the way to go. You have to be prepared to work outside your comfort zone. You know, we did not have experience in high throughput testing. Certainly very few people had on the scale that we're now doing it. But you know, if you try and people are prepared to work hard, this was not done by people working 9 to 5. Most people were working much longer hours, 6, 7 days a week. Another key thing to do here, as I was campaigning for funding, I identified lieutenants that I could rely on to get things done. As you know, some people like to talk and some people actually deliver. And I identified a couple of people that I knew were going to be able to get things done. And once we got the green light, I could assign them areas of responsibility and turn them loose, so things happen. Also, what was very important was to manage expectations and decide on what level of high throughput we could do. You know, it is high throughput, but it is finite. We were approached by a number of people saying, can you help us? And we had to decide who we could help and who we couldn't. There was very close integration of campus and City of Davis, as well as the county health efforts. And I think this was really key to having the impact that we did. And then finally, you know, this was supported by a totally committed administration. The message was get it done, and things that would normally take weeks took days, things that could take days took hours. And this was really key to rolling this out. And so with that, I will finish.
Richard, thank you so much. That's it's such an amazing story. I really appreciate you taking the time to run through it so quickly as well. And I'm sure there'll be questions in this short panel session we have coming up a little later. I should say this effort has gotten quite a lot of national media attention, New York Times, multiple TV stations as well. So rightfully so, an amazing example of moving a research concept and idea, translating it amazingly rapidly and getting such great buy-in. So I'm sure we'll have hopefully a few minutes to discuss a little bit later. So thank you for that, Richard.
Yeah, I would say, I mean, reaching out across to different academic institutions, you know, monitoring for variants of concern. This is an ongoing opportunity. And if anyone wants to talk to me about that, the LGC is interested in early access sites. The assays are ready to go. And right now I'm having to push back with the CDC. You know, they really want to sequence. And I think that is the wrong way to go. So I'm encouraging people to get on board and genotype. And I think it's a question of build it and they will come.
Fantastic. So hopefully we'll get a few minutes to touch on that later as well. Thanks, Richard. Okay, I'm going to switch over to my colleague, Dr. Ana Lucia Cordova-Credos now. Ana Lucia is our Strategic Initiatives Manager in the Office of Research, and she's just going to provide a short snippet of some of the efforts that we've been making in a more slightly traditional way, I guess, in trying to keep the research community together and stimulate activity related to COVID-19, not specifically in any way claiming to have helped Richard's project other than just some conversations, I guess, but just as some of the other things that have happened on campus. And what we're trying to figure out, is there a way of bottling Richard's success and other stories that we'll hear and kind of formalizing it in some framework. So Ana Lucia, over to you.
Good afternoon. I'm just going to very quickly walk you through what happened in our group, the Strategic Initiatives Group, back in March. So we were faced very quickly with an unexpected challenge of, unexpected and unprecedented impact to our campus. Our campus closed, or the closure of the campus, including a lot of the research activity, was announced on March 13, 2020. And it was a Friday. It was a Friday the 13th. So it was very on point. So our team immediately, we were all sent home, but we were asked to continue doing our work. And we were asked to consider the fact that we were now going to have all these challenges and opportunities to contribute to generating research, solutions, options for how to help our community in face of this pandemic. So we quickly got together and we started thinking, what do we need to do? So we were faced with all these challenges. How do we contribute to a solution? How do we maintain research continuity that now that our researchers cannot, a lot of them cannot come into their labs? What do we need to support the COVID-19 and pandemic related research across all disciplines? Because we are a campus that has one of each. As I tell people, it's a strength, but it can also be a challenge. So we have people in the social sciences and humanities, and we have people like Richard who are in the middle of the fray. So how do we equally support everyone? How do we encourage people to embrace all of these opportunities for funding so that they can continue doing work? And how do we make sure our researchers actually have access to all the information and the resources that they need? So in summary, what do we do as the support and staff team to make sure our researchers are successful and that they can continue to thrive in these challenging circumstances? So what we did is we decided, we sat down, we talked about it, and we said, okay, there's 3 things that we need to focus on. We need to make sure that our researchers have access to information in terms of who has what, when, how do I get an IRB, how do I get access to samples, how do I get access to the lab facilities, where are the facilities, why do I need to do this way? Our researchers were coming to us with all of these questions from all over campus. And we had never had to answer all of these questions at the same time for hundreds of people at the same time. So that was a challenge. How do we deal with information that comes from all over campus? Other challenge was people. Now people were not on campus. They were not coming to meetings. We were having all these Zoom meetings. We were trying to figure out how to do everything virtually. And we needed to be able to connect all of these researchers. We needed to connect people who needed reagents or a particular facility or a particular lab with people who had the skill or the students or could provide training. So that was another challenge. And then the funding. We needed to be able to support people to quickly shift what they were doing in their lab. Maybe they needed seed funding, maybe they needed access to supplies. And then we were also managing this huge influx of information regarding funding opportunities. And we needed to figure out a way to push all that information together in a holistic, useful way. So information about resources, information about people, and funding and access to funding. So what did we do? So we launched a seed funding competition that was open to absolutely everyone on campus. Anyone who was doing social studies all the way to sequencing and epidemiology studies. It was very challenging to turn it around because this was something where, you know, we might run a seed funding program that takes a few months to run, and we needed to announce it today and start giving money funding to our researchers by the end of the week. So we were able to fund 20 projects, and those projects, along with other researchers on campus, have turned into over 250 submitted proposals with over $150 million of proposals total, and 96 awards totaling around $35 million. Now, not all of that those success stories came from our funding, but we did put in place a lot of mechanisms that assisted and encouraged our faculty to apply and help them in moving these proposals that were rapid response out of the office quickly. We made this like big kind of suite of communication platforms. So we provided a bi-weekly forum for researchers to come to the table. It was like a no agenda forum, just come to the table. People would come in and say, I need to do sequencing, but I don't have enough capacity. I don't have reagents. I'm trying to figure out how to get my IRB. So we provided kind of like a desk, a help desk, where people were coming into us twice a week. And it also allowed us to make connections. So we might connect Richard, for example, with other people, or people who had questions about sequencing, we might send them to another person, and so on and so forth. We started having these like COVID-19 research town halls every week, where we were inviting people to come in, sometimes with just their research ideas of things that they wanted to do, and they needed feedback from the community at large. It was very important that in these town halls, we were also engaging our School of Medicine, because again, this was like a public health issue that we were dealing with. And then as part of that town hall, we were able to bring in a lot of high profile, high caliber speakers, like Professor Jennifer Doudna, who was the Nobel laureate this year on chemistry. We had Kathleen Kiriko, who developed some of the technology that is fundamental to RNA vaccines. And Professor Lawrence Corey too. So we built this big forum that has now transformed into a team research forum, where we're now applying these same kind of principles, methods to bring the community together to other areas that are ripe for participation. We provide a lot of communication platforms, websites, email lists, curated funding opportunities. So a lot of virtual online tools to bring people together, to push out information efficiently, and as well as information funding opportunities, and help people connect with each other. So we're hoping that what we learned in this rapid response to this research challenge that the pandemic presented is something that we can now take a look back and build into a toolbox that we can use to then apply to other research challenges as they come up for our campus, but also for other research institutions where might be useful. That's all I have. Thank you.
Okay, thank you, Ana Lucia. Sorry, we're a little bit over time here, just with the difficulties at the start. So with no further ado, I'd like to hand over to Randy Larson from University of South Florida as our next speaker.
Thank you. Yeah, I'm going to do a really quick overview of the response of the University of South Florida. I know we're pressed for a little bit of time. So I have a slide on the background that shows our pandemic response research network. Obviously, at the onset of the pandemic, universities were challenged with how to respond. And the pandemic really represented a global challenge that universities, I think, are really uniquely suited to address. So universities possess extensive intellectual capital and infrastructure really across wide disciplines that allow us to be able to coordinate efforts and address on a relatively fast timescale, as we've already seen, when we have these kinds of challenges. So at the University of South Florida, the Vice President of Research convened a task force. So we started by putting together a task force of roughly 40 faculty members from all over the institution, representing nearly all of our colleges, to really take a look at where are our strengths and where is our physical infrastructure that could be deployed to address various aspects of the pandemic, which includes both mitigation and the consequences, the human consequences of the pandemic. So what we formed within, and it was amazing, I think as Richard pointed out, the speed at which we were able to put teams together, at which we were able to get administrative support was really staggering, and is a real testament to universities pulling together when they needed to. So in a very short time period, we were able to assemble this task force, and the task force rapidly identified areas that USF had unique strengths, where we had assets and where we had physical infrastructure. And we came up with roughly 9 kind of broad research areas, which we refer to as research hubs. And if you look at the diagram behind my head, my coronavirus corona, those are basically our research hub areas. And they include what you might imagine. They include the biomedical side, which was critical in the early days, understanding SARS-CoV-2 virus, understanding the spread, developing therapeutics, beginning to think of vaccines, surveillance and epidemiology, which was a major issue in the early days of the pandemic. But what really, I think, was really exciting about the PRN, that our Pandemic Response Network, was that we also identified very quickly that we have behavioral, socio-emotional, and educational issues. We have there were environmental consequences to the pandemic, and this is certainly true in the state of Florida, where we were facing multiple crises at several points during the pandemic, which included, what do we do when we have hurricanes? That's a real problem for us. How do we shelter? We never, who had considered that as a major issue? How do you shelter in a pandemic? How do we open up shelters? Where do we put them? What are the consequences of mask orders? So there's more than just the biomedical side. And so we identified research hubs that extended far beyond just the biomedical side to it. And I don't say that lightly, that it's just the biomedical side. The biomedical side obviously was a major component. And then also we recognized pretty quickly that our communication technologies had to evolve rapidly, and there were going to be consequences to that. There were going to be economic consequences to that, and we're still seeing the effects of that. What happens when people don't have to go into their offices? How are we communicating? How are we working with schools? How are we working with our kind of online education? So all of these things really represented a multifaceted challenge for addressing the COVID-19. And the way our network is set up is that each of these hubs has a hub coordinator or set of coordinators. And these are faculty members that have research interests in these areas. And then underneath, if you could look actually underneath each one of these hubs, are sets of faculty clusters, and not just faculty clusters. There's community partners, and there's industry components as well, that are all brought together to tackle the problems. And when you look at this and kind of deconstruct it, this really is HIBAR. We're bringing in multiple stakeholders to tackle a specific problem. That's a global problem. It's a community problem, and to do it on rapid timescales. And one of the concepts of HIBAR is that we really need to bring the right stakeholders together to accelerate the translation from the basic research to the translation. So in deconstructing something like our HIBAR network, it really, or our pandemic network, it really is a HIBAR approach. And again, I think as Paul has pointed out, we don't always know it's a HIBAR approach until we do it. And then we go back and look at it and realize, yes, this is exactly what HIBAR is supposed to do. And for us, the benefit of this is moving forward, we now kind of know what kind of HIBAR elements we can put together to make these kinds of networks to actually tackle other global problems. And the pandemic really showed us what we are capable of. Much like Davis, we had an institutional internal funding program. We put in about $1.5 million. And we also have something called the Florida High Tech Corridor, which matches some of our funding. And so we were able to infuse some additional resources. And so we made sure that the internal grants were distributed among all of our research hubs. And so we saw projects funded, ranging from increases in domestic violence during stay-at-home orders, all the way to vaccine development. So it was really a broad scope approach. And again, it highlights the university's capacity to be able to handle and address kind of multiple issues on these global challenges. And I think as we'll see when we end this, that the lessons that we're learning here is that we can address through these kinds of networks and these kinds of approaches problems beyond the pandemic and beyond these kind of immediate challenges, because I think we could also argue that most of the global sustainability challenges are immediate crises. We don't see it that way, but they are immediate crises. And one of the faculty members who was involved in our PRN as also one of our plenary speakers today, and I'm really excited. Yeah, I love this project from the beginning. So I'm glad we're going to I get to see the round of it. Is Dr. Sylvia Thomas from our Department of Electrical Engineering. She's an associate professor with us. She has a lot of industrial experience. I think that brings a lot to the research effort. And again, that's HIBAR components. That's how we bring these elements together. She also leads the Advanced Materials Bio and Integration Research Laboratory here at USF. And rather than listen to me talk, I think I'll pass it off to Sylvia, who's going to talk about another area that's really important for the pandemic, which is the big data approaches to the pandemic. So, Sylvia.
Awesome. Thank you, Randy. And thank you all so much for having me here with you today. I greatly appreciate that. And so I just want to have a conversation with you today that talks a little bit about an effort that the National Science Foundation has funded in addition to the work that we've done with the USF PRRN, and that is to use big data to fight COVID. Looking at early detection of disease outbreaks using self-organizing patterns. And this was an interdisciplinary effort across electrical engineering, myself, who looks at sensor data, and computer science and engineering, our industry partners, Graphaware and Graphable, and also our consultant from internal medicine. We also had graduate students, Radita and Saray, that actually assisted with this effort. So it was a great effort in terms of looking at what we could do to solve a real problem that exists in society. And that is when there was the beginning of the outbreak. We wanted to understand the symptoms and the transmission, but we were doing it looking at proximity data, right? Geographical proximity data, and trying to relate the outbreak and trying to track the outbreak based on this geographical proximity data. But the issue was there was a delay in detection, there was a delay in the containment, and the delay in prevention. So that created a critical need to actually investigate a model that could in fact track the spread of the disease based on topical proximity. So looking at words, phrases, different topics that appear in medical journals, that appear across doctor notes and dictation and things of that nature when we partnered with our doctors. So we wanted to address that critical need, and I checked today, and the actual cases are actually up to 32 million. And so we proposed a solution with this particular proposed work supported by NSF. And that solution was, easy to access, easy to use big data, where we look at topical proximity knowledge graphs. So we would use machine learning, data analytics, natural language processing to actually gather thousands and thousands and thousands of data points to look at clinical data and to look at clinical prognosis using our industry partners software, the HUM software. So in doing that, we were able to gain network relationships across causes and across, known diseases, and actually networking, right? And relationships among those. So some of the key insights that I wanted to point out in terms of the knowledge graphs that we've been able to develop is that we see that the knowledge graphs are being used as global, or can be used as global indicators of how we can actually find the underlying causes of pandemics and the patterns and the distribution, right? Also using the knowledge graphs to show early detection of the disease outbreak using these topical proximity nodes and networks. These databases can also overcome our critical limitations around reliance on the spatial geographical proximity. In addition to that, we can track faster, and we can track globally. It doesn't have to be a localized tracking. In addition to that, we can detect subtle changes in research patterns leading to these outbreaks. And lastly, I just like to say that we've seen that the knowledge graphs have an ability to rapidly identify drugs that can be repurposed or not repurposed to combat pandemics. And so if we were to take a look at an example in terms of that repurposing, then we have to consider if we were to take and do some data mining, we've extracted the top 13 genes here across a series of articles. And so what we notice here is that the knowledge graphs can help us find relationships among genes, diseases, biological processes, compounds, right? These pathological pathways and side effects. And for example, if we look at the TLR7 here, right? When we look at that receptor, which assists in the sensing or recognizing of foreign receptors, particularly if we expand this node here, looking at TLR7. And so if we go on and even do a deeper dive and look at actions that may occur, maybe pointing to some drug repurposing or not, here, these knowledge graphs provide us a look at the drugs that inhibit or turn on, right, the TLR7. And it's adapter protein, right? So you also see the adapter protein here. And so you have such drugs as your cyclosporin here, which is used for your immune suppression in transplant patients. And that can inhibit the TLR signaling. In addition, you have your hydrochloroquine, and it also inhibits the activation of TLR7. And we know that hydrochloroquine was initially targeted at the virus. And so by connecting these structured data, we can actually look at existing compounds capable of regulating genes or genes, looking at gene interaction. And when we do that, and we actually look at the entire network, right? And we pull together the fast access using these knowledge graphs, then we can also come up with some fast answers. But if we take a closer look and we zoom into this relationship, this network relationship that we have here, we see here that your hydrochloroquine is likely, as I said before, inhibitors for your TL9 and your TL7, by some common mechanism, right? So compound combines the gene. Well, you also have your systematic lupus that's part of this network, and it's an autoimmune disease, and it's also throughout this network, and it has a viral trigger in some particular cases, and that viral infection could also trigger the TL7 and your TLR9. So it looks like maybe, right, your hydrochloroquine can in fact be a good drug or be repurposed. But our knowledge graphs, once we pull in all of that data that we're data mining, shows that hydrochloroquine is associated with multiple or a multitude of different disorders and pathological effects. So the question becomes, what if we had known this earlier in terms of the utilization of hydrochloroquine? So our knowledge graphs, just to hone in, our knowledge graphs can rapidly provide a greater understanding of the impact of repurposing a drug and to use big data to combat pandemics. And it can also be used across other research platforms, again, to help centralize some of your efforts. And it's almost like, right, reverse engineering your particular investigation. And so I also want to point out some synergy with HIBAR in terms of our basic knowledge that we used for this particular research, using 6 main databases, thousands and thousands of data points. And so that basic knowledge was used as building blocks to create these knowledge graphs. In addition to that, we used techniques, applied techniques, to transform the data into these knowledge graphs. It was partnerships between, academics, industry, as well as medical experts to address the societal need. And in addition to that, out of this work, that same cluster or same team has involved a social scientist to further this work, to look at integrative research ecosystem to investigate health disparities across COVID as well, where we look at underserved or underrepresented minority communities and how we can track some of those symptoms using this big data as well. And so I just want to thank you for the time, and that is some of the work that we did.
Wonderful. Maybe I could address a question to both Richard and Sylvia. And Sylvia, maybe I'll ask you first. I mean, if you could extract, what are the key things that you've learned from this approach, this really fascinating approach that you've developed? How much of it, or what of it, do you think could be deployed to other major research questions? Do you think you could reproduce this kind of success and rapid progress in other research fields that you might be interested in, for example?
Absolutely. As I said, we've actually, branched it off into looking at other avenues. One of the key things, and one of the exciting things, is that I am an applied researcher, right? So most of my work is hands-on and in the lab. So when COVID hit and we were not allowed to go into the labs, I had to do some out-of-the-box thinking in terms of how to continue to engage in research efforts and to actually try and help with the crisis and what was going on. And so out of that evolved this work. And so I definitely think that the basis that we've established here can be attributed to other things, and again, bring in additional researchers from other areas that can contribute.
Great, thank you. Richard, same question to you. I mean, if you could bottle this experience, because it's been quite an amazing roller coaster ride for you, I'm sure. Do you think there's elements of this that you could imagine replicating for other major societal challenges?
As someone else touched on, I mean, what was remarkable was how fast the university could respond. When we said, okay, make it happen, and directions came right from the top, make it happen. And I say, you know, we were purchasing the equipment in a matter of days rather than weeks. We needed to hire people to get that through the system. Would have normally taken 2 or 3 weeks. It took 2 or 3 days. You know, to get approval for something that normally would take 4 or 5 days happened in hours. And the frustrating thing is, why the hell can't we work like this all the time? You know? And I know it got prioritized over other things, but it shows what's possible if people want to make it happen. Yeah, and I think the integration with the City of Davis has been really good. That sort of whole Healthy Davis together. And, you know, we have had a somewhat sort of town versus gown dynamic at times that wasn't always productive. But right now, I think it's really, really helped. And I think there will be other problems that if we take that approach, you know, we'd bring the schools back, we're doing sewage monitoring. I think also the lesson, well, 2 things too. One of which is the lesson that science really is a good thing. And I don't know, Davis is known as the Republic of Davis, okay? It is extremely alternative. And I think there's a growing realization that science does have a useful role. It isn't a bad thing. The other thing I think will be useful to push the message out is, if you don't believe in evolution, just look at what's happening in COVID, right? I think that's a message we can push out. You're watching evolution happening in real time. And the biological world evolves and changes. And for the doubters, people that want to take evolution out of the curriculum, I think we have a very good example of saying, how do you explain what's going on here?
Amazing. Great points. I once heard a former mayor of Davis describing the town as 9 square miles surrounded by reality. So there certainly is an element of a little bubble here, but there's definitely, you know, the work that you and that huge team have worked on have had a profoundly positive effect on, you know, the surrounding areas. There's no doubt. So I want to ask Randy a different question, if I could. You know, we've heard 2 quite different examples today, but you know, do you think this is an opportunity to really further deepen engagement with non-academic or non-university based researchers and practitioners? I mean, you know, the examples that you gave in your overview touched on many different disciplines. So could you maybe comment on that? And again, within this notion of the HIBAR framework, what can we extract?
Yeah, absolutely. There's a good example of that. So we started, you know, so kind of building on our PRRN, we also built another network that's very similar to the PRRN that addresses anti-Black racism. And in that network, we took a lot of lessons that we learned from the PRRN about how to engage with our communities first. And one of the really interesting observations that came out of our discussions about that is that universities have had a tendency in the past to collect research areas and then go to the community and say, do we do anything that will help you? And it may or may not. What we're not asking the community is, where do you need help? And we'll build some networks around to help you around a problem you need to solve. And in these kind of social justice networks, that's the approach we're taking now, which is really a paradigm shift from the way we have traditionally done things. And that is, you get the community engaged from the beginning and you find the problem they need to solve. Although we do outstanding research and scholarship in all of our universities, we don't always take the approach of, well, what does my community need? And then let's build something around, and we may have assets already at the university that could address that problem. We just haven't identified that as a problem. And if you look at, these kind of research hubs I have behind me, why can't we build a hub around a need in our immediate community where we already have assets, we already have strengths. They're just not coordinated to work on that problem. They're doing other problems. So I think there's a huge opportunity here to now shift the way we think about things in terms of engaging either industry partners, our local communities and corporations at the beginning. And I think with the HIBAR, I think that's really something that's exciting because in our approach, this network approach, the idea is we build these hubs around the problem. We already have a lot of faculty here doing all kinds of things, but we identify a problem, we build the hub around the problem, bring the faculty clusters, partners around the problem, and then that's how we tackle the problem. So I think it's kind of a new way to, certainly for our university, it's a new way to approach research problems rather than just traditional, we have areas of strength and we continue to grow in areas of strength, and that's where we focus. How about we take those areas of strength and look at where the real problems are, and then shift those faculty clusters around. So I think there's enormous opportunities for these kinds of what we're calling now HIBAR, kind of collaborative HIBAR networks.
I think that's the key, the responsive part of HIBAR, right, is directly addressed there. Earlier in my career when I worked in industry, the framework that's used for R&D within a Six Sigma environment heavily emphasizes VOC, or voice of the customer, to your point of you actually need to know what exactly the end user really truly needs and wants, rather than presuming you know what that is. So I think that's a key point. Lauren, I wanted to bring in you for a second, if we have a few more minutes, just to talk a little bit about, or think about how can, and a question, does the HIBAR framework and the tool sets that are being developed in any way help, say, academic-based researchers in that pursuit of being responsive?
Well, that's an excellent question. One comment I would make in that direction is an observation, and I really appreciated your comment about voice of the customer, which really has permeated the non-university world almost thoroughly. But that wasn't always true. There was a time when, in fact, that was not a normal way for corporations to think about how they met the needs of their customers. And so I think, in a sense, that same transition is happening now in the university system. And one way that I like to think of it is it's easy to imagine that it might be very difficult for leaders in society to work well with leaders in universities collaboratively to achieve common goals. It could be that it would be just difficult to get a meeting of the minds, and that would just be plagued with all kinds of difficulties. And that can sound true if you haven't actually tried it and found the good news that no, actually, of course there are challenges, but they can be overcome, and it's worth it. So to me, that's the exciting transition that I think our system, really the worldwide system of universities, is beginning to understand more thoroughly.
Great, thanks, Lauren. Sylvia, if I could put sort of a slightly similar question to some extent to you. I mean, did you find that it seemed in your project that you were working with people significantly outside your discipline, and in fact, of course, outside the University of South Florida with industry partners and others? Did you find communication being a barrier at any stage? I mean, were you able to, agree quickly on what the priority areas of things to do were? Could you talk about that a little bit?
Sure, definitely. I'm laughing because the dynamics that in our team meetings, when you have a medical doctor and an electrical engineer having a conversation, it's almost like we have to have tutorials going both ways, right? Yeah. In terms of understanding the terms and being able to identify what the clear research focus is and what the high level objective is. And I think that was the key thing. We all agreed, okay, how can we effectively use this tool to make an impact on decisions, right? And some empowered decision making that happens in society. So in working with our internal medicine consultant, he was blown away in terms of the data we could collect, but he said, how could I use it, right? So we talked to him about how he could use it, how we could streamline the data to give him information to make informed, like about drug repurposing, and for me in particular, if I use some of the data, we could also look at different sensor data, right? So different sensor data can come from everywhere, and so I would like to see some sensor data and what that data looks like. There was a question in the chat about what do you do about misinformation or misconstrued data, things of that nature. And so the cool thing about the knowledge graphs is that, we can have a node that identifies 2 sources, but then another node that is connected to that same gene or compound has 2,000 sources. And so we drill down and take a deeper dive, right, in that node that has the 2,000 sources. But the communication was challenging in terms of us working across all of those different disciplines. But I think key was we knew what the objective was.
Richard, if I could put the same kind of question to you, I mean, could you imagine this process working that you were involved in with such a big team of people as well, if there wasn't such absolute desperate and dire and immediate need? Was that an important element here? I mean, and the question then is, if that wasn't there, do you think this would have worked to the same extent?
Not really in terms of communication of language. I think managing expectations was really important, right? In terms of what we can do, what we can't do. Also, there was something, people were really hung up on exactly what was the false positive rate, what was the false negative rate, this kind of thing. They really wanted data, what is the real positivity rate in the community and things like that, rather than taking a step back and saying, what are we trying to achieve here, right? Is that some people were very hung up on process rather than deliverables, which was interesting. I think one of the things that we should think about is one of the biggest challenges of our times, probably more so than COVID, is climate change. And how can we take the lessons from because people have really got behind, let's deal with the pandemic. But if we don't deal with climate change,
forget about it.
We might as well not have dealt with the pandemic. It's a really big challenge. And that's going to be much more multidisciplinary. It's going to have all the social components and everything else. So I think if HIBAR wanted to really take a challenge on, it's how do we deal with climate change and use the type of resources and type of thinking.
Yeah, great points. Any final comments just before we wrap up? Our Randy, our Sylvia, or our Richard?
Thank you for the opportunity. Get the message out.
Yeah.
Absolutely. Thank you very much for having me. Thank you, Randy.
Yeah, I agree. It was a very exciting afternoon, and like Lauren said, I learned something every time. And just if we could try to figure out how to keep this kind of momentum, and I think as Richard, if we could just convince our research administrations that we can solve a lot of problems if they let us.
Right. Very good. And on that note, I want to thank everyone for participating and sticking with us.